So hello everyone guys, my name is Dhananjay Mishra and today we'll be discussing another problem of the day. So the name of this problem is matrix chain multiplication, right? So before moving further, can you please let me know whether my voice is audible and my video is perfectly audible to you or not? Uh, After you acknowledge me whether my voice is audible to you or not, we can move further. Yeah guys, can you please let me know, am I audible to you perfectly or not? Yeah guys, can you please let me know? Yeah, so I think I'm perfectly audible, right? So before moving further, uh, before moving further, let us now discuss that is what was the problem, right? So I'll do let me know if my screen is visible to you. So so this is the problem of the day, right? So this problem says that actually uh, the name of this problem statement, as we discussed, that it is matrix chain multiplication, right? As you can also see that it is a hard level problem, right? So let us now read the problem statement. The problem statement says that we are given a sequence of matrices, right? And we have to find the most efficient way to multiply these matrices together. And the efficient way is the one that involves at least number of multiplications, right? So what does up till now? It means that we are given a sequence of matrices, right? And the matrices are denoted in the form of array. That means to denote a matrix, we basically need the dimension of that matrix, right? So in that array, we will be given dimensions, right? So we will see it later on how these matrices are denoted, right? After that, then we once we are given these matrices in the form of the array, right? So we have to find the most efficient way to multiply these matrices together. That means that suppose if we have you know right. So suppose if we have three matrices, or let us the example, if we have these four matrices A, B, C, D having some dimensions, right? So there are a lot of ways to multiply these matrices, right? Before moving further, there is a property of matrix that says that if given two matrices, that is A and B, right? And if you want to multiply both of these matrices, then A cross B is not equal to or same as B cross A, right? So as we saw in that integers and numbers property is that if you multiply two numbers, suppose 5 into 3, it will always be equal to 3 into 5, but this not happens in the case of matrices, right? So you should note that thing is here, right? So before moving further, you know the problem statement said that, I hope this thing is clear to you, right? So this problem statement is a very interesting one, right? Trust me. And with this is the classic problem, right? And it is also called as MCM, and yeah, that means matrix and multiplication. And the concept behind this matrix and multiplication is used in a lot number of questions, right? I will tell you the questions in the end of this live stream, which of the questions are based on this matrix and multiplication concept, right? So yeah, so where were we? We were discussing about that. Is suppose we have four matrices, right? So there are a lot number of ways to multiply all these matrices together and to get a final matrix, right? What I'm trying to say, that if you are given a matrix A cross A and B, and if you multiply them, you will get a single individual matrix as a result, right? So similarly, if you have A, B, C, D, four matrices, right? So what you can do, you can multiply these A, B, C together and then multiply C, D together. So this will give you a single individual matrix. Let us name it as X, and it will give you a Y matrix, right? After that, you have to again multiply those matrices, right? So this is the one way of multiplying. Another way of multiplying is if you have A, B, C, D. Let us take it again. Another way of multiplying is you multiply B, C first, right? After that, it will give you a single matrix, right? So the matrix reduced to us will be AXD, right? Now again, you can have multiplying AX together first, then multiply D with AX, right? The result of AX. Or what you can do, if you have AXD from here, you can multiply XD first and then multiply A with it, right? The result of XD. So I hope you're understanding that there are a lot number of ways of multiplying the matrices if you are given, right? So we have to choose that order of multiplication such that it gives us the minimum cost of multiplication. Now, what is the cost of multiplication, right? How can we derive the cost of multiplication? So the cost means the number of multiplications you will be doing, right? Suppose if you are given two matrices, this and this. So how do you do multiplication? Suppose if we have number 3, 5, 7, 2, 1, 3, and take it 6, 7, 8 here, and here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So how do you do matrix multiplication? So what you do basically is you just pick up this row, right? You just pick up this row and multiply all the elements with all these first column of that second row, right? And you put the result in the first column or the first cell or the final answer, right? Again, you pick this row, multiply it with this one, put the answer here, multiply, again pick this row, multiply this one, put the answer here, right? So in this manner, now secondly, you will be picking up this entire row, multiplying it this one, this one, this one, and you will be getting answer, right? So the cost of multiplication is, I hope you're getting that. If you have dimensions n cross m and here m cross p, one more thing you have to note here is that you can only multiply the matrices if and if their column number are same, right? That's why I've written n m m and m m here, right? That means the column number of the first row should be equal to the row number of the first row, right? Then only you can do multiplication. So keeping that in mind, the cost will come out to be n cross m cross p, right? So this is the cost of multiplication of two matrices, right? That is its number of rows into the number of columns, because if you are multiplying two matrices, then the column should be same, right? That means this m factor will be common in both of these, and the last one is the p, that is column of the second matrix, right? So this is the cost of multiplying two matrices, right? If and if only the matrix multiplication is possible, right? I hope you understood the rule of how we can multiply the matrices. After that, after understanding what does it mean by the cost, we will learn about how these matrices are denoted in the form of array, right? So it said that we are given a sequence of matrices. So they are given a linear one-dimension array, right? And the matrices are denoted in that. So by having a first look at this, anyone will not be able to understand how the matrices are denoted, right? So there is they have defined a particular rule for defining a single matrix, right? What they have said that that is the dimension of the matrices are given in an array of size n, such that n is equal to number of matrices plus 1. So we'll be coming back to this point, right, later on. What does it mean? So where the ith matrix has the dimension array of I minus 1 into array of I. So if I pick this array, right, and denote all the matrices they are forming. So if I pick this array, so the array was 40, 30, 20, 10, and 30. I guess that was it. Okay, so there is a swap here. That is, it will be 20 and 30 here, right? So these were all the array given to us, and n was equal to 5, right? So as said that one matrix will be denoted by array of I minus 1 into array of I, right? That means array of I minus 1 denote the row number, the number of rows, and it will denote the columns, right, the dimensions. So as it is quite logical that we don't have any negative indexes. So if I start from this index, marking all my matrices, it will not be possible because it is at 0 index if I mark the indexes also, right? So it is a 0 index, and it says that to get a row of a particular matrix, we have to get one step back to array of I minus 1. But here, if I do array of I minus 1, I will get a minus 1. So it is not possible, right? It will give us an array. So error. So that's why we will be starting from index number 1 and start looking at the matrices that can be formed. Okay. So the matrices that can be formed will be that is, first matrix formed will be, I hope till now it is clear to you guys what I'm trying to say. So the first matrix will be of dimension 40 into 20, right? The second matrix will be of dimension 20 into 30. The third one will be of dimension 30 into 10. Like this is the first matrix, the second matrix, the third matrix, and the fourth matrix, right? So the fourth matrix will be 10 into 30. Right? Now, as you can see, there are total number of 4 matrices, right? So here it is saying that such that n is equal to number of matrices plus 1. So basically we had n equal to 5 here, and the number of matrices possible were 4, right? So that's why n is equal to number of matrices plus 1, that is 4 plus 1 equal to 5 in this case, right? Now after understanding the question, right, we will move on to the approach we will be getting, right? How to solve that question. The approach now says that again pick this matrix only, that is 40, 20, 30, 10, and 30 again, right? So as discussed earlier, we had choices, right? We have choices of multiplying. So as you know that if we have choices of multiplication, then we have so will not be assured that which order or which choice of picking the order of multiplication will give us the minimum cost. So that means the idea is that we have to try each and every possible combination, right? So for that means we have to apply the brute force approach, right? Why brute force approach? The idea is that we have to try every possible combination. There is no other way of solving other than it, right? Every possible combination. So guys, I hope you are understanding that whenever a new question comes to you in which you are getting an idea that you have to try every possible combination and there is no other way of solving that question other than trying all the possible combinations, you should always go with the solution will lie in the brute force, right? So the idea is that, right, so for trying all the possible combinations we have a recursion, right? So now up till now we are clear that we will be using brute force approach, and brute force approach means recursion, right? Up till now it is clear that how we categorize this question into a particular topic, right? So yeah, that means recursion. So basically we are clear that we have to use this topic tag, that means we have to use recursion, right? By assuming and by analyzing it logically. Now what will be our recursion look like? The main task is that, right? So our first step is clear that we determine the brute force approach and that means recursion. Now our step is that how will be determining what will be our recursion body look like, right? So now so basically here, right, we had 40, 20, 30, 10, and 30 again, right? So the point is that try each and every possible combination. What you can do, you will do some partitions, right? Because suppose you will do because if I do partition here, it will not fetch me any matrix, right? Because it is a single dimension. So I have to start from here, right? Now if I do a partition here, what matrices will I get? The first matrix will be 40 into 20. The other matrices I will be getting will be 30 into 10 and 30 into 10 and 10 into 30, right? So now after I do a partition here, after or I can say after I divide my array into left and right sub array, so I will get this matrix and this matrix. So I can solve this as a sub problem and this again as a sub problem, right? After solving all these sub problems, I will be adding their answer or the cost, right? So now I hope you're analyzing how we are dividing this problem into a relatively smaller number of problems and then adding up their answers, right? I hope now you're getting the idea of something better than recursion. So now what we can, as you can see that the sub problems are of same category, right? We have to find the cost, right? So now to try so the main question was how do we try each and every possible combination. So this is the manner we will do partitions, right? And we will divide our array into sub arrays. So once I get this as a single array, so I can solve it easily. Now if I come to this part, again I have two arrays, right, or two matrices to solve. So again I will do some partition, right? So the first partition will give me here So in this sub problem, again there are sub problems, right? So we have 30 into 10 again as a matrix, right? And 10 into 30 again as a matrix. So that's how we will be solving it. So in this manner, we will be dividing, or trying all the possible combinations. To understand it more firmly, I will take an partition of here also. So what do you think? If the partition here will work or not? Right? Yeah, it will work, because if I do a partition at this point, the matrices I will be getting will be 40 into 20. This will be fetching me the first matrix, right? And 20 into 30, right? 20 into 30 and 30 into 10, right? So the next matrix will be 30 into 10. Now if I do a partition here, the last matrix I will be getting will be 10 into 30. So 10 into 30. So now, this is a single matrix. There is no cost, right? Here, we will come to the point when we have a single matrix. What is the cost of that, right? So now here, right? Here again we have three matrices, right? So we can again follow any order to multiply those three matrices, right? So again we have to divide this three matrix into some simpler problem to solve for us, right? So that's how we'll be doing that. So I hope the topic of recursion is clear to you. So before moving further, I understand this problem is a pretty complex to understand, right? And so I would like to ask every one of you the question, that if you up till now have any doubts, so that I'll cover up your doubts and move further, because I don't want you to have doubts in your head, and you move on with the next next thing in this topic with those doubts. So if anyone has any doubt, you can ask me. So after that, we'll be moving further. So I hope everyone has understood up till now pretty much clearly. Okay. So I hope that I hope what I'm trying to do is briefly clear to you, right? Now moving further, as we discussed that we will have a recursion solution, right? We will have a recursion solution. So basically, a recursion solution, what does it look like? Our recursion solution, let us name it a solve function, right? So our solve function, we have to return a cost, right? So our cost, this solve recursion function will have a return type of integer, because we have to return some cost. So it will have this return type and the parameters that I have to pass. So talking about the parameters, right? You can see that once we divide this array into sub problems, we have a particular range, right? That is, this will be my start and this will be my end, right? Similarly here also, right? If I divide it in this part, we had these metrics, right? If I divide it, so this was my start and this was my end for the left part, right? For this left part, this was my start and this was my end. Now if I divide it further, suppose from here, right? From here, so again I will have two matrices, two partitions. That is, for that it will, the start and end will be pointing here, and the start and end will be here, right? For the second one, for the second one. So I hope you are getting that we have to pass a range. So for passing a range, what we can do, we will have some start pointer and an end pointer depicting our range, on which we are finding the cost for all the matrices lying in that range, right? Now after solving the issue of parameters and the return type, what we will do? So the basic idea is that we saw that we will be partitioning our array and looking at further, right? So now that point comes out to be where up till what point our range will lie, right? Because in this question there are some edge cases. For this one, for example, 40, 20, 30, 10 and 30. For this example only, if you can see that if I start my range from here, right? If I put my start pointer here and end pointer here, do you think that it will work? No, it will not work, because if my start is here, to get a matrix, I should have a previous dimension also, but it is not possible. So our start will not start from here, right? So our start will start from here only, right? So our start will start from here. I hope it is clear to you, right? Now talking about the end. Now, if I talk about this end, this will work fine, right? Because if I take my end here, this will work fine because we will have a base case that if I have a only single dimension, that means start will be equal to end, or my start will be greater than end. That means, we don't have any metrics, and then we can normally return the cost from it 0. Why 0? Because if you don't have any metrics form, then what will be the cost of its multiplication? It will be 0, obviously. So that's why if our start will become greater than end and start will become equal to end, that means we will be returning 0. But this will work logically, right? But once coming to the coding part, I will show you that we cannot take our end here. We can't take our end here. We have to take end till here, right? It will give us an error. Right? So we have to take our end here. I will tell you because while understanding it is sounding quite logical, right? But once we come to the coding part, I will tell you where this will give us an error, right? So now I hope this is clear to you, right? So we have a range. Now what we will do was defining our range. I will be doing partition one by one. Suppose, so for doing partition one by one at this index, at this index, and this index, it sounds pretty much logical that I have to use a for loop for each partition, right? Once I will do partition here, then here, and after each partition I will be calling my recursion function twice, right? Twice. Why twice? Because if I have this one, so if I do suppose partition here, right, so I have to solve for this problem also, right? So for this problem I will be calling, my start will be here, right? So what I'll and if this is my partition, right, suppose the partition is denoted by a variable k, right? So this will be my new range and this one will be my new range, right? So I will again call my the same recursive function twice. Why again we are using a recursive function is that we have to solve the same sub problem again and again. So that's why we use recursion, because recursion is a function that calls itself again and again. So I will call for this left part my recursion function solve, as start will remain same but the end will be shifted to this point, right? I hope you are getting it. So my end will be k, right? Now for this recursive, for this right part I will call again my recursive function that will, now for this the start part will be k plus 1, right? Because we are partitioning here, so this one will be k plus 1, right? This one will be equal to k plus 1 and end will remain same, right? So in this manner, again if I will be calling this thing again, so if I do the partition of this point again, so again it will be calling this solve function again and again. Why? Let us now look how recursion function actually works, right? So to understand recursion perfectly, how it will be working, we draw a recursion tree diagram, right? So suppose we have a recursion tree diagram here, right? And let us now look how recursion works. So these nodes represent state of my recursion. State means, that is, if I did a partition here, so I called this one function, right? And the right function also. So this is my left state and this is my right state, right? So that's, these nodes depend the denotes the state, or we can call the number of recursion calls, right? We are making at each state. So this was, suppose this is for my left part and this is for my right part. Now how recursion works? Recursion will work in the DFS manner. That means it will keep calling its left child again and again until it reaches the last, that is the leaf node, right? So how recursion will work? It will keep calling itself again and again, right? Just keep a notice or mark where my marker is moving, right? So in this manner recursion works. It starts from here, it keeps moving in the depth first search manner, that is till the depth or in the left part till it reaches its leaf node, right? And then it comes to the right child, right? It moves in this manner only. So that's why I'm saying that once I have called, that's why I was saying that once I called this part, so it will again call this part again, right? And like this part, it will take this subarray and it will start partitioning on this array until it gets its answer or it reaches to the base condition. One more thing, the leaf node denotes the base condition, right? So now talking about the base condition, I hope the general case is clear to you, right? Now the base condition, what about the base condition? So our base condition is that if my range is only having a single dimension, that is start is equal to 1. That means if I am left with 40, right? So for this start is equal end, right? So I can't form any matrix. Similarly, if my start reaches out greater than equal to end, right? That means also that, you know, if this is my if I have 40, right, and my end is pointing here, then my start is pointing somewhere here greater than end, right? It is also not logical, right? So that's why these two are our base condition, and once we reach our base condition, that means we will return 0. Why 0? Because in these base conditions we will not be able to form any matrix, right? And if you're not able to form any matrix, that means there is no cost of multiplication. That's why we'll be return 0. Now I hope that the working of this recursion function is clear to you. Now we will look onto the code how this recursion function will look like, right? So as discussed, we have a return type of integer. Let us name the recursion function as solve, right? And what we will be passing, we will be passing that array, right? The range, right? I hope the range is also clear to you, right? So we discussed that the range will start, or the might start in the initial call to the, so when we call the solve function from the main function, so we'll pass in the first call, the start will be pointing to the first index and n will be pointing to the last index, that is n minus 1, right? Now just note that I will remind you again that why it will not work n minus if I keep it to n minus 1, right? Okay, but that means this is correct, but I will tell you why we cannot iterate till n minus 1, right? So I hope the initial parameters are also clear to you. Now how a recursion body will look like. So first of all, we have a base condition. So I hope the base condition is clear to you. If my start is greater than equal to end, that means I have to return 0. Okay, up till now it's clear. Good, that's good. Now as we said that we will have a partition, right, at each and every index. So for that I have a k that will denote my partitions. So it will start from start, right? And it will, okay, what we assume, it will go till end, right? And k plus plus, right? Up till now I hope it is clear to you, because we assume that we can do partitions up till this end. So these are all my dimensions, and we assume that we can do partitions up till now, because we assume that if I do partition here, after that we will be having an empty array, and this empty array will be taken care by this base condition. This empty array will be taken care by this empty, this base condition, right? We assume this, but I will tell you now why it will fail. Okay, so before reaching to that point, let us now discuss what we will be implementing in this for loop, right? So I discussed that we will do partition, and we will keep this left part and right part, and we will be calling our recursion function again for this left and right part. So one more thing now, I have called, okay, after calling solve this left and for the right part, we will get a cost, right? But are you sure that the cost we will be getting from these partition, from this, let us assume that we are doing the first partition here. So are you sure that this first partition will be giving the minimum efficient cost that is asked to me? No, right? Because we have a lot of choices. So out of all those choices, or out of all those partitions, I can say I have to choose the minimum one, right? So we are not sure that at this partition I will get the final answer, or at this partition I will get the final answer, or this partition I will get the final answer, right? So after doing all the partitions, I will pick up or choose the minimum one, right? The minimum cost of them. So for that I will be keeping a temporary variable that will be storing my temporary cost for each partition, right? So now one more thing is that we assume that this solve function once, so what did we assume that, so basically from this main, right? So from the main function, if I had a main function, right, from this main function we call this solve function to calculate our answer. So what we are assuming that this solve function will give us the minimum cost, right? And we will return the answer we fetch from this solve function. So we are assuming that it will give us the final answer, right? So keeping that thing in mind, because noticing this thing is very important. So now keeping this thing in mind, we are sure. So if I call this solve function for this left part, for this left partition, so we will be sure that this solve function will give me the minimum answer for this left partition, right? So I will call my start, and as we discussed that our end will be in the left part, our end will be reduced to k. Now plus for the right part, my start will be changed to k plus 1 and end will remain same. Now okay, so one more thing here is that we are done with calculating the left and the right hand, the left and the right partition, right? So if I take this example A, B, C, D, right? So what I did, I just did, I did this partition. I called my solve function for this left part and this right part also, right? Now, do you think that this is much? This is it? No, because as I said, these two metrics when multiplied will fetch me a single matrix. Let us name it that single result as X. Similarly, this multiplication of C and D will fetch me a matrix Y. So now we have to multiply these individual metrics or the result metrics of A, B and C, D respectively also, right? So we have to add the cost of multiplication of these X and Y in the cost of left part and in the cost of left part and the right part also, right? So how we can do that? So as we saw that the cost was, if I had the metrics and dimensions, let us suppose 40 into 20 and 20 into 30, right? So what was the cost? Cost was 40 into 20 into 30. That means the left hand part, this middle one, and this the rightmost part, right? Now, so you can see that, right? We will get an answer if I do a partition here, right? That means you are multiplying the matrices, right? So that means these B and C these B and C should be equal, right? So, and this is our range, right? And in this one, this was our range, right? The start of this range was this and the end was this, right? So what we'll be doing is that for calculating the cost of this X and Y, we will if this was our range 40, 20, 30, 10 and 30, right? So, and if I want to calculate the cost of this one, what will I do? So I will take this one, and suppose if I did partition here, right? If I did partition here, so I will take this one kth in the dimension at kth index and the end one. I hope it is clear, right? Because you can analyze it from here, right? This was our start and end and the kth one, right? So the cost will come out to be 40 into 30 into this 30, right? So that's how we will be taking the cost of this. I hope it is clear to you, right? So that's how we will be taking the cost of the final result matrix of the multiplication of left and right part, right? So what will I do? I will pick array of I minus 1, or I minus 1 I can say it here because we had start, right, for the range, for the beginning of the range. So what I will do, start minus 1 into array of k into array of n, right? That was it. That's it. So after adding all these costs, we will get a temporary answer for that particular partition, right? Now, as we told, as we're seeing that this is a temporary answer, right? So we have to check out of all this temporary answer, what will be the minimum one. So I will have an answer variable and I will keep the minimum out of it. That is answer and temporary, right? And once this loop is over, I hope it is clear that why I am doing this answer is equal to minimum temporary of answer, because after each partition I will get an answer or the cost, but we are not sure that whether this cost, the cost for the temporary one is the final answer or not. So to ensuring that it will be a final answer, I will be doing all the partition with the help of this loop, right? And after iterating till the end, we'll get several temporary answers. So out of all these temporary answers, I will be putting the final minimum answer in this answer variable, and finally I will be returning that answer. I hope it is clear to you, right? So up till now in this recursion approach, anyone have any doubt? If yes, then you can comment it down. Okay, so yeah, so I was telling about the error it will give us, right? Now, so what is the error? Right, let us talk about the error. So if I took this, okay, if I take this matrix only, Now what I said, that this will be my start, cool, and this will be my end, cool. So now what error it will give if I iterate till less than or equal to end, till end, right? If I do my partition here, right? So again, what will be my range, right? So I hope you are getting that this will be my left part and this will be my right part, right? So there is no issue with the right part, right? So because if I call this for the right part, it will give me 0 because start will be greater than end in this case, because my start will be pointing here, right? And my end is here because we kept end same, right? So it will reach out this base condition in the next call and it will return me 0. So for the right part, it is clear. There is no issue with the right part. But for the left part, you can see that my end is here and my start is here. So if I call my recursive function again, so again I'll be passing the same range. Correct? I'll be passing the same range. And in this range, again, if I reach till end here, I will be passing the same range again. So you will be traversing or doing computations for the same range again and again. So it will not end. It will not reach an end, right? No end to it. So because we are using recursion, the stack overflow will reach and it will give us a segmentation fault, right? Segmentation fault will be given to us because we are done with all the stacks available to us by the compiler and all. So I hope you're getting the logic, because if we reach till end, we will be calling this range again and again because we are iterating till end here, right? So that's why instead of keeping it equal to end, I will just keep it till end, less than end, right? Why it will work? Okay, so let me show you again why it will work, right? So if I have this one 40, 20, 30, 10 and 30, right? So I am not iterating my partition till this one. I am iterating my partition till this one. So I have this one, right? So it will fetch me 0 because this will be my start and this will be my end, right? So it is a single dimension, right? It will fetch me 0. Cool. Now my range is this. In the next iteration also, if I call for this partition also, my start will be this and my end will be this, but my partition will reach out till here, right? Again, so you can see that I am reducing my search space, right, by one element at each recursion call. So that's why it will not give me an segmentation fault, because after reducing, it will at some time it will reach at this single element in the left part, right? So it will not give me segmentation fault. So that's why we are only keeping it to k less than n, not equal to n. I hope it is clear till now, right? So now one more thing you should observe here, that as this is exponential time complexity, right? This is exponential time complexity. Therefore, so if you can imagine that it will have some repetitive problems, right? How repetitive problems? I will make you imagine and visualize, right? So okay, so if I take this example again, right? So okay, so if I do my first partition here, right? So I will be calculating for this matrix and for this matrix, right? Cool. Just keep in mind that we have calculated for this matrix, right? Now again, if I move by partitioning and I reach here, right? So what matrix I will be getting? 40, 20, 30 and 10, right? Now this is again a sub matrix or my sub array, right? Or sub problem. So I will start partitioning from here only. So again, I will be doing partition at some point here. So I will get 40, 20 again. But notice that we have calculated in the first partition itself, the value for 40, 20 itself, right? So why do we need to compute it again here? That's why the concept of dynamic programming comes in the game, right? As we are having repetitive problems, we can store those problems, the answer for those sub problems, and I will be getting the final and use the answer for those sub problems in the future use, right? As you can see here, because we had computed for this answer, and now for this partition we had this this matrix 40, 20, and again if I do partition here, I will get a subarray here, right? And in this subarray, if I want to do the computations or iterations again, I will because I have to keep, because after doing this partition I have this left subpart, and I have to do partitions in this left subpart also, because to consider each and every case and choices, right? Because we are doing it brute force manner. So if I again do partitions in this left sub part, I will be doing a partition here again, and I will again fetch 40 comma 20 like this here. So why it need to compute again? So that's why we will be storing the answer in the first moment when we solve for this, and using that answer here also, right? So that's for dynamic programming. So basically dynamic programming is what, you know, dynamic programming is simply brute force plus storing, and it is normally called storing is normally called memoization, right? So that's all about dynamic programming. So okay, so we are done with this recursive approach. So we will just do a bit of changes in this recursive code, right? So as I told you here that sorry, as I told you here that there is nothing much about dynamic programming. We just have to store the answer at each and every particular state, right? To visualize it more furthermore, if I draw this recursion tree again, right, and let us suppose that this sub problem is same as this sub problem, right? So as I told that a recursive function works in DFS manner, so it will start from here, here, here. Once it's solved for this one, we will store this the solution for this state somewhere. We will be storing it, and once I reach here, I will see that yeah, I have stored the answer for this sub problem here. So I will be using that answer here again, right? So I will not be doing computations again for this sub problem, right? So I'll be storing, or I will be saving my time and computations here. So that's all about dynamic programming. So let us now see all the changes we will be making in our recursive code. So where was our recursive code? So yeah, so I will add down my code again, recursive code again, right? So it looks nice and clear. So this was our recursive code, right? I hope everything is clear up till now to you. Right? We had this start and end, and yeah. So we had a base condition, that is if start is greater than equal end, I will return here 0, right? And I will be having an answer that will be initialized to int max. We'll leave some space. Okay. So we had a variable answer to store the final answer for that particular state, right? So that means for this particular state, right? For each state we have an answer, and that answer we have to return it to its parent state, right? That's what all we do in recursion. So we will initialize our answer as int max, right? After initializing, we have a loop, right? So we had a loop that is int k, it denotes our partition, or we can say the partition index. So we discussed we will be iterating till less than n and k plus plus. That's it. And we'll having a temporary variable to store the temporary answers or temporary cost for each partition. So at the left part, this is for our left part, right? Left partition. So we will in the left part we will be having start as same for that range, and end will be shifted to k, plus the right hand part, the right part, right? For right part, our start will change to k plus 1 and end will be as it is. Now the last thing was multiplying the final result matrix of these left and right multiplication, right? So that was done by array of start minus 1 into array of k into array of end, right? That was it. And after that we were just choosing the minimum out of all these temporary answers, and we were returning it. That was it, right? That's all we did in the recursive part, and we just return the answer. So now, as we discussed in the dynamic programming, what we will be storing the answer, right? So how we will be storing the answer? So before returning the answer for this particular state, we will be storing it. So we will be keeping a 2D array. I will tell you why 2D array, why not single or 3D array? Because we were computing for this range, right? Start to end. So that's how we can represent a range in 2D, that is using start and end. And one more logic is there for using this 2D DP array, right? So after storing it, we can return the answer. Now one more change we have to do here is that, so before computing or calculating for a state, we will be checking whether we have stored the answer previously for that state or not. So for that, we will check if my DP for that particular range, I have stored my answer or computed my answer previously or not. For checking that, I will be check whether it is -1 or not. Because if it is -1, that means the answer for that state is not is pre-computed and we have to compute it. If else, the answer is or dp of start of end is not equal to -1. That means the answer is pre-computed and it is the final answer for that particular state. So I can normally return it from here. That is dp of start comma end. Right now, the question comes: why 2D array? Why 2D dp? Right. So how do we, how do we check what will be my state of dp or of what dimension my dp array will be? The answer lies that the total number of variables you are keeping in your recursive function will be the dimension of the array, right? Because those variables are changing, and that's why you have to, because of those variables, you have to, you are doing computing all those possible answers you will get. That is brute force, right? So in this, you can see that two variables are start and end, denoting the range. That's why our dimension of the 2D array or the DP array start from end, right? I hope guys it is now clear to you. So that's all in the discussion part. Now we will move into the coding part. Right, up till now, if anyone has any doubt, you can let me know, and because we will be moving further with the coding part. Right. I hope no one has any doubt. So yeah, let's begin with the coding part. Okay, so this was our question, right? And okay, so moving further. So what we did? Okay, so first of all, we were calling a recursive function, right? And the dimensions we passed in the recursive function was our array, right? 1 as a start, because as we discussed that why 1, why not 0, and end will be n-1, right? And as we have to return the answer, because solve will give me a value, right? So it will return me an integer value, and we have to return that integer value, right? So basically solve is our helper function, right? The main function, we can say. And this one is a start of this range, right? And this n-1 is our end, right? Now let us move on to the main helper function, that is solve, right? So we passed an array and we had a start, right? And we had an end. Now after that, we had a base condition. If that is, if my start is greater than equal end, I will return 0, right? And okay, so currently I'm writing only the code for recursion, right? So, and after that we had an answer variable initialized to int max, right? And now we did some partition. We'll be doing in this loop the partitions. It will go till less than n, and we discuss why less than n, right? And after that we have a temp variable to store the all the temporary cost we will be getting after each partition in that range, right? So we'll be calling the left part array, right? Start will be as it is and end will be shifted to k. After that we will be calling for the right part, that is for the right part our start will be shifted to k+1 and end will remain as it is, right? And after that we computed the cost after we get the result matrix after the multiplication of the left and right part matrices, right? So that will be array of k and array of k, right? That's it. So if I comment it down for you, so it denotes my left part or the left partition. It denotes my right partition, and it denotes my cost of resultant matrix multiplication, right? So that is it. And after that we will be taking the minimum of all the possible answers. You guys can see that how the small this code is. The only thing is about uh, finalizing finalizing the logic and what you will be doing with the recursive function, right? And after that we will be returning my answer, right? That's a recursive function. Now, as we said that there are a few changes in the lines we have to make it into a DP code. So what was that? First, before computing or reaching in the state, we'll check whether the answer is computed for that range or not. If yes, not equal -1, then we will return. That means the answer is pre-computed for that state earlier, and that is the final answer, right? Uh, so I will return dp of start comma end. That's it, right? And after that, before returning the final answer, I will be storing the answer for that range before returning, right? So that's it. Now we will create a DP array, right? So how will we be creating a DP array? As you will look at you can look here that the maximum dimension is of this array was 100, right? So what I will do, I will take the worst case, that is the maximum dimension, because we are declaring it globally, right? So we will take 101, right? So it will cover all the cases, all the edge cases, and once it is declared, we have to initialize it with -1, right? We have to initialize it with -1 because we are because -1 denotes that the answer is not computed for that particular range, right? So that's why initially the answer for any of the state is not, or any of the range is not computed. So initially all the all the ranges will have the answer as -1, right? So for that I will be using the memset function -1 size of dp. So basically what this memset function does, it just take this array, the size of that that data structure, or the what all data structure you will be using for storing or memorization, and put and initialize all those values in the -1. So yeah guys, that's all about this one, right? That's all the code, and I hope the code is also clear to you, right? And we'll try to submit it. I hope it will get submitted. Okay. Yeah, so it is giving an error. Okay, so it has it. I was not declared in this row. So basically, yeah, it is not I here. It is start, and then yeah, that was all the typo error, and I hope it will work now. Okay. Okay, one more error we made. The silly mistake we made here is that, right? So now I hope it will run perfectly. Yeah, no error up till now. Yeah, so you can see that guys, it is working correctly. Now one more thing I told, that what if I take this equal, right? Equal sign. So I told that it will give a segmentation fault. Let us now check it. As you can see, it is giving a segmentation fault, and the logic I gave it to you, that why it is giving a segmentation fault, right? So to make it work properly, I will only do less than, right? Now it will be working fine. Right guys, so that's all about today's this problem of the day. I hope you enjoyed it. And okay, if any guys has any doubt, so you can answer or ask me, right? I hope no one has any doubt. Okay, I think I have made you understand pretty much clearly. So yeah guys, stay tuned to this practice channel. Happy coding. Bye bye.